Okay, in Chapter 9, Garner's going to review some basic skills for crime scene processing. We're not going to review some of the things that Garner has reviewed because, for example, fingerprints are well covered in an entire course on fingerprint identification, so I don't really see a need to repeat it here in this particular course. However, if you feel that that subject's a little weak, you might want to review what Garner's had to say about it. So with that, we're gonna get started and look at some basic skills for processing. In this chapter, some of the objectives are explaining the use of the alternate light source, or ALS. The ALS is also known as an FLS, forensic light source. We are not going to explain, however, the basic methods of fingerprinting, because as I mentioned before, this is covered in a term-long fingerprint identification class that's part of this curriculum. Neither are we going to identify the four basic characteristics that define the method used to fingerprint a surface, because as I mentioned before, those are covered in another course. So coincidentally, you are not responsible for those particular chapters. Now we're not gonna get into too much depth and detail about fingerprint searching, but we may address some of these issues when we talk about processing arson scenes. However, we are going to spend a fair amount of time in identifying the primary techniques of recovering impression evidence. First, we're going to talk about light energy. Light energy is measured by its wavelength, which is the length in nanometers that's measured from one peak to another peak. In fact, you're going to see that referred to when you're looking at some of the alternate light sources. We're going to talk about how many nanometers and colors and things of that nature. Needless to say, the higher the energy level, the shorter the wavelength. Shorter wavelength, the greater the ability, however, to penetrate objects. For example, gamma radiation. Gamma radiation penetrates and will disrupt living tissue. However, going with a much longer wavelength, mid-range ultraviolet, however, will cause sunburn. All right, let's talk about the different parts of the light spectrum. For example, X-ray energy occupies the 1 to 200 nanometer light spectrum range, and these are commonly used for medical imaging, X-rays, CAT scans, things of that nature. Okay, in the 200 to 400 nanometer range, you're going to find things such as shortwave ultraviolet and long-wave ultraviolet. It's this long-wave ultraviolet that's commonly referred to as a Wood's lamp. And Wood's lamps were used in medical diagnostics to diagnose eye injuries. What we use light in this spectrum for, rather, is in reflected ultraviolet imaging systems, which are going to be discussed in the Week 4 video assignment, and often used in gynecological examinations for finding biological fluids. Visible light occupies the 400 to 700 nanometer range. In the 400 nanometer range, the light tends to be blue to blue-violet, whereas you get in the 700 nanometer range, it appears red. And then in the light that exceeds the 700 nanometer range is often referred to as infrared. This particular light in this spectrum has a number of different uses. They can be used to excite certain chemicals such as indane DFO, and some of our fluorochrome dyes that will be discussed also in the Week 4 video presentation. Okay, infrared energy occupies the 700 to 2000 nanometer range. It was used a lot and still is used quite a bit for surveillance imaging at night, but it's also used forensically for injury documentation and also used for detecting altered and obliterated writing. Then finally we have heat energy, which occupies the 2000 to 12,000 nanometer range. And the devices that utilize heat energy, since you can't see it, are things such as the forward-looking infrared imaging systems, or FLIR systems, that are commonly used on helicopters and such. FLIRs are not commonly used in crime scene investigation, although they do have certain applications in arson investigation. But even in arson, the utility is pretty small. Regardless of your situation, light is necessary for searching a crime scene. If you've ever tried to search any scene at night, or do any sort of search at night, you'll find out just how necessary of a tool it is. In fact, if you do get a scene at night, it's usually a good practice to try to secure this scene and search it in the morning. Therefore, clean white light is absolutely necessary for basic observation. There's a lot more you can see in the daylight than there is at night, or even with a flashlight. Now, the alternate light source provides tunable light energy that you can use to make different types of evidence visible. And this is where the alternate light source provides the greatest amount of value. Now let's take a look at how an alternate light source works. First off, there's usually a source of light. Oftentimes it could be a tungsten or a halide light source. An excitation filter is placed in front of this light, which filters all but a specific wavelength of light. After that, the light strikes the surface. Some energy is absorbed by the surface, and electrons become excited and they start to glow. Meanwhile, other energy is reflected. And then these excited electrons fall back to a normal energy state after they release their energy as light. And this release is at a lower energy state than original light. And then finally you have a barrier filter that keeps the original wavelength from passing, but allows fluorescent energy to pass and be seen. If you've ever used the forensic light source in your fingerprint identification class, you'll find that the evidence actually becomes more visible when you put on the barrier goggles. And the barrier goggles will allow some colors of light to pass and others will be blocked. The idea of which is to block out the reflected energy and allow only the original wavelength energy to pass. So that way you don't get as much surface reflection interfering with your image. And this is an example of alternate light source fluorescence. Now they have, with this barrier filter, blue light is eliminated, so the only thing you see is the red that's coming from the object being fluoresced. Now, alternate light sources are particularly helpful when you're looking for different things, such as biological fluids. Certain fluids will fluoresce when they're excited by a alternate light source, especially one that's tuned to a certain wavelength. Fibers in some hairs will fluoresce too, especially those fibers that had to be dyed. Bruises or bite marks are useful when illuminated by an alternate light source. Tattoos could also be included in this as well. Enhancing and visualizing nearly invisible blood stains, that is a possibility, although this is the application where you want to include your alternate light source with a fluorochrome that reacts with blood, such as Hungarian red. And ALS will also help with detecting document alteration. Now that we've discussed alternate light sources in the crime scene realm, let's talk a little bit about casting and casting impressions. Casting material is usually used on rough or irregular shaped objects. In this particular case, we have a fingerprint that was visualized with black powder on an irregularly shaped object. The problem is, how are you going to lift that impression off of that object? The method of choice in these cases is to use some kind of casting material, such as microsil. Although there are a lot of other casting materials on the market, and some are better than others in the particular application. This is where you want to get to know your material and perhaps practice with it on non-casework until you understand its limitations. Impressions will occur in a number of different ways. For example, shoe marks, footprints, tire marks, and tool marks are the ones that are most common, and they may appear as two-dimensional or three-dimensional in appearance. Some of the basic on-scene casting and lifting techniques include rubber and silicone compounds, electrostatic lifting devices for dust prints, plaster and dental stone for three-dimensional impressions, although they can also be used for two-dimensional ones, and gelatin and other adhesive lifters for two-dimensional impressions. Rubber casting or silicone casting usually involves mixing a rosin and a hardening agent together. And this particular picture on your right was a tool mark that was captured using microsil. Microsil is a silicone rubber-based casting material that is squeezed out in equal lengths and then mixed together. However, if it's possible, you want to recover the actual tool mark. If there's an object that bears a tool mark, you're better off to recover the entire object. But there are some occasions where you just can't do that. For example, you may not be able to capture tool marks on a sliding door or window, because the homeowner might get a little upset if you took a Sawzall and cut up his window frame. This is the time where you want to photograph first, with and without scale, and then use a rubber casting compound. The electrostatic dust print lifter is a handy tool to have, especially when you're trying to capture not only shoes and tires, but you can also use it for capturing fingerprints on an object. There was an occasion when I was working in Michigan where an individual had gained access through a false ceiling. He happened to leave his fingerprints on the wall frame in the ceiling, and the only way we could capture those adequately was with an electrostatic dust print lifter. What you're seeing here is an electrostatic dust print lifter that's a commercial device. There are others that are made out of stun guns, and that too can also be useful as well. Then we have plaster or dental stone casting. These are usually used when you're attempting to cast a three-dimensional impression, such as a footprint or tire impression in dirt or sand. Before you capture any impression, though, you always want to photograph first, with and without scale. You then mix dental stone and you would pour that into the impression. Once it's dry, you remove the cast. Casts are usually placed in boxes, and if the cast has some dirt adhering to it, it's generally best to leave the dirt alone and allow the footwear or tire track examiner to remove the dirt once he gets the cast. Finally, there's gelatin and adhesive lifters. These sort of things are not only useful for footwear impressions, but they're also useful for palm impressions, large fingerprints, especially if you're trying to capture multiple fingers and multiple joints. You always want to photograph these impressions before using them, although they can often be very successful. They're utilized in much the same manner as you would fingerprint lifting tape, in that you would tack the lifter down and then roll it across the impression. The roller that you see in the photograph is used to make sure that the lifter is flat against the impression. And then finally, once it's removed and the impression is lifted, you would then place a clear plastic cover over it to prevent further damage. Now this concludes our discussion of impression evidence. We're going to go through some of the actual mechanics of using this equipment in the impression lab that follows.